Hi again, my name is Carrie Copay and I am your VLI online instructor for biology labs. This is our first lab, Lab 1, and it's using the microscope. Remember, we're going to refer back to our lab manual and all the contents of our lab box for doing the lab. There's some additional supplemental materials that you're going to have to use this week, and I'm going to talk about those as well. So you're going to start with your lab manual, you're going to start with your kit, and you're also going to refer to Buzz. So don't forget that all this information is archived and collated in Buzz for your reference. So make sure that you don't just hit on the Dropbox for the assignment that's submitted, but actually open the folder in Buzz that's going to actually lay out for you what the expectations are for this week. So starting with your first one is which lab manual pages are we referring to? So first up here in our lab manual, we're going to be working off of page 1. And if you reference your first lab here, you'll find that it as well says using the microscope. So that's where we're starting here. Some things you're going to need around the house, it's also listed in Buzz on the landing page. You're going to use some newsprint, so find a newspaper that's lying around and just grab a little corner of it. It does need to be newsprint because it is a little bit thinner paper than conventional paper, and we need that to be able to see through it on the microscope. Other thing you're going to need is some hair. So you're going to need a strand of hair that I plucked out of my head. And then you need your microscope that we have here. Okay, so those are additional things that you're going to need from your house or that have been provided to you that don't come in the kit. But what does come in the kit that you're going to need is your microscope box. So inside here you're going to find that you have some cleaning cloth for cleaning your lenses as well as cleaning slides. So that's inside of your container. And then you have cover slips. So you'll find the cover slips here that we're going to be using. In your dissection kit here, you're going to use some tools out of here repeatedly through the lab, so make sure you put them back in the dissection kit so you have them for future labs. And those things include a dropper and scissors. Just for handiness, I'm going to be using my own here. And in your lab, it actually lists what items and where to find them. So blank slides, we covered those. The cover slips here, an eyedropper, little plunger guy, and forceps from the dissection kit, a pencil, and scissors. Again, the scissors are found in there. And the materials not included says newspaper, microscope, a cloth, strand of hair, and some water. And so I have a little bit of water here. All right. So we're going to be walking through your lab. As you go through your own lab, make sure and take your pictures so that you have those for your lab report. And then at the end of our lab, we're going to complete that template here, so you should probably start with this template for your lab write-up as you go through your lab. So make sure you get this from Buzz. This is in addition to your lab manual and going to be your lab write-up. And then you're going to answer those questions that are in the lab manual here that start on page 7. And all of those are going to be in your submission here for online labs each week. So let's get started with your microscope here. And part of it is learning how to use the microscope. So in your Buzz, you have 2 videos this week that you want to review. The first one is the microscope and using a microscope. And that's going to go over all the parts of our light microscope. And this is called a compound microscope. And I just plugged it in and turned the light source on here with the back of the switch. And that's going to illuminate my stage. And just like you think of the theater, the stage here is where all the activity happens. So this is your stage, where you're going to be putting your specimens and your microscope slides. They go on here, they have slide clips, and that's where you're going to actually put your specimen. So the light comes through here, and at the bottom is a condenser and a diaphragm that controls how much light passes through into your specimen on the stage. And so you can control how much light is passing through by rotating what's called the diaphragm, and it is an opening that lets so much light in. The next thing here is we have our nose here on our microscope. And this is why the microscope is called a compound microscope. It's because your image transfers from your stage up through your eyepiece by passing through 2 lenses. Not just one, but 2 lenses. The first lens is actually your eyepiece. And you can take it out, but you have to put it back. And this is a magnification of 10x. So power of 10 right here. So we have just 10x magnification, so your sample is going to get 10 times bigger by looking through just that eyepiece. But in addition to that magnification, there's also a series of 3 different lenses here on the nose. Starting with our low power in red, that has a magnification of 4 times. So just like when we think about exponents, we're going to multiply the magnification that is received by passing through this first objective lens times the magnification of our eyepiece to get the total magnification on a sample. So we have a 4 times magnification at our objective lens, and compound that with a 10 times magnification of our eyepiece. So on low power, our sample is magnified a total of 40 times magnification. So 40 times more than we see with our naked eye, just on low power. So these are pretty sophisticated microscopes you have here. And this is actually a teaching microscope because I could look at this sample here along with you. Yours probably is just a simple compound microscope with just one eyepiece. So this nose, we can rotate this microscope to the next highest power. And that's our 10x objective. And that's noted on yellow. So this is 10 times magnification. And you have, again, you're compounded with your eyepiece of 10x. So now we're looking at a sample under 100 times magnification. So now imagine your little tiny image is blown up 100 times, zoomed in. So you're getting a nice image with medium power. And then if we rotate our objective even further, it goes to 40x. So now you're 40 times 10, 400 times magnification. And if you can observe here on this eyepiece, on this objective lens, you can see the length of the objectives change, right? So we get our lowest, then our medium length, and then our highest length objective. And that's important because you don't want to smash your slide. So if you imagine you put your slide onto this stage, so if I put a slide onto this stage, and I put it here, okay, I always want to start on low power because then you're not worried that you're going to be too high on the stage and jam your objective lens into your stage. So always start with your stage at the lowest position, and these knobs here adjust your stage. And then you're going to put your specimen into focus by raising and bringing that stage up and looking through your eyepiece. In this lab, we won't use goggles because it would probably interfere with us using the eyepiece. So we don't really need goggles for this lab. Okay, so your video here is going to walk through and explain this more to you and help you to review it. These microscopes are what we call parfocal. That means that once you put your specimen into focus on low power, and always do it on low power, as you go up in magnification, your specimen is going to stay in focus. And so you aren't going to have to adjust the level of your stage. You may have to fine-tune it, and to fine-tune it, you're going to use a fine adjustment knob. And you can see that I'm adjusting this knob down here at the bottom, but the height of the stage isn't changing at all. And so that is not going to have it your slide smashing into the objective lens. You're just fine-tuning it. And once you have it fine-tuned on your medium power, then you can go up to your high power, and likewise, you can use your fine adjustment knob here to adjust it and bring it into focus. Okay, so that's some important things about the microscope. We're going to watch a video about the parts of the microscope, so you get that information recorded. When you finish with your microscope, let me just close with how to put it away. Make sure that you always take your microscope slides off, that you return your objective lens to low power, so when you're ready to start again, put your stage back in its lowest position, turn your light off, and wrap your cord around it. Okay, and always carry a microscope with 2 hands, one hand on the base and one hand on the neck, or I think it's called the arm, technically. Okay, so that is proper care of your microscope. And there is a troubleshooting video if you find yourself not being able to find your specimen, and that's on your videos for this week. All right, so let's just jump into what our labs are. You're going to be looking at how to prepare a wet mount. So wet mount, this is kind of a cool property of water. You guys learned about the properties of water probably in your biomolecules. So here's your cover slips that you're going to need. And these cover slips here are just little thin glass. And you'll notice that they don't stick to glass, like the cover slip won't stick to glass. But water, because water is a polar molecule, right? Back to water being a polar molecule. If I add a drop of water, that water acts like glue, and voila, the cover slip sticks to our slide. That's, remember, our cohesion and adhesion properties of water. Okay, so water bonds with other water molecules and water bonds with surfaces that have a charge. So here is our water sticking to it. And that's how you're going to make your cover slips. So in your microscope, the first one here is your newsprint. You're going to just take a little corner of an E. Make sure you have a little lowercase e. A little lowercase e. I'm sure you can't see that. But we're going to put that on our microscope here and make our wet map by putting a drop of water and then covering that with our cover slip here. And now I've created a wet mat. Now you're going to put this under the microscope just like you would be reading it. So imagine here I could read this word me. It says me, M-E. So I'm going to put it on this microscope so it's facing me. And I'm going to center that E over my opening, where my light comes through here, so that the E is facing me, because what we want to see is what happens to that image under the microscope. You're going to find that you don't look at it in the microscope, it's not going to look like just a giant E. It actually transposes that image because it's a series of mirrors that are flipping and rotating your image. So you want to record what that E looks like. It shouldn't look like how you see the E. You should not see your E like this. Okay, your E should not look like that under the microscope when you're asked to draw it in your lab report. Okay, you should put it on the microscope so it's facing you that way, but you're going to find that your image of the E is not that way. You need to record how you see it. And then the other thing you'll find is that when you move your sample on your stage from left to right, that your image appears to move in the opposite direction. So those are the kinds of things you're going to be asked to observe under the microscope as you go through here. The other thing you're going to be looking at in your microscope is a strand of hair. So you're going to do the same thing here. You can use the same slide, take it off, and you're going to be putting a single strand of hair under the microscope. So make sure you get rid of your newsprint. And then you're going to you can cut your hair so it's shorter, and lay it on the microscope, and you're going to make observations about your microscope. Okay, so that is going to get you through your lab this week. And again, as your lab report, your final things are documenting yourself with your equipment, completing your lab report with the statement of purpose, the hypothesis, your conclusion, and it includes the lab pages from your lab manual and pictures documenting your activity. If you have questions, refer to those videos on Buzz for this lab, and then email me as well, and I'm happy to help. So good luck this week.